Hello, everybody. My name's Professor Richard Sinnott. I'm going to talk to you today about some work that one of my master's students completed, Zijam Wang, which was focusing on linking user accounts across social media platforms. Unfortunately, I'm unable to be there physically, which is a bit of a pity, but hopefully this video will be enough to raise some interest and we can have a conversation afterwards. Just a bit of background. So I am the director of the Melbourne Research Group. I have a large team of software engineers. We work on all kinds of different projects. And most of these projects tend to be focused on data and security. I also get to supervise literally hundreds of master's dissertations. So students at the University of Melbourne have to complete a master's dissertation in order to graduate. And there are lots of students. So I teach cloud computing and high performance computing. And typical classes are now into the several hundreds. I think when I teach next semester, it'll be maybe 500. So Zijam was one of these students who I supervised. This was his master's dissertation that he focused on. I have been doing lots of work with social media for a long time, mostly Twitter, but many other platforms too. And we've been collecting this data at scale for a long time now. Social media data and social media platforms and social media data has many of the hallmarks of what we now regard as big data. It's very voluminous. It can be created very rapidly. There are a range of platforms now. They have a range of formats for the data. So your Twitter and your Instagram and things of that nature have different flavors of data, I guess. And one of the key challenges of social media is the veracity or the truthfulness of the data, which, as everybody knows, this is really where a lot of the social media work falls down in terms of the trustworthiness of the data. There is a lot of use of social media. It's ubiquitous now. I guess you can say there are nearly 3 million users accounts in Australia alone, people who are using Twitter. And the data is pretty much near real time these days. And a lot of the time you can geolocate it. So if you're using a mobile device to tweet, for example, or for using Instagram or any of these kind of platforms, then if your location service is turned on your device, then you can find out who tweeted where. People are probably unaware about the consequences of what information they're releasing when they make a tweet, for example. They're actually that little character string that they're submitting about, whatever it might be, the topic, it contains about 9 kilobytes of data. It tells us about what device you're using, where you are, what language you're tweeting in, who you follow, who follows you, etc., etc. And it's very easy to build profiles of people around this and track them and do things of that nature, which naturally has implications for privacy. And a lot of my own research is in the privacy area, how to obfuscate data and protect it so that people can't be as easily re-identified. A lot of these platforms, which I'll talk about in a little while, have APIs. So we don't scrape. We're not using, collecting data from any social media platform that doesn't have an API. We don't really focus on that one at all. But a lot of these APIs have various limitations imposed. So they are rate limited. You can only get certain amounts of information out of them. You can't go back in time very easily. So you can't say, what did Donald Trump tweet in 2016, etc. And you only typically, when you're using these APIs, get about 1% of the tweets in the last 10 days or so. However, as of this year, platforms such as Twitter is now making available its whole archive, where we're getting much, much more data now. And so we're getting millions of tweets every few weeks, basically, as opposed to just a few hundred tweets every few minutes or so. I mentioned that social media is kind of ubiquitous now. Everyone's tweeting or using all kinds of flavors of social media. So we've been doing a lot of work for a long time now, as of many others with Twitter. There are APIs. There is a streaming and a search API. Well, there are other platforms that we're also focusing on as well, which including Reddit, YouTube, Flickr, Foursquare, and online gaming platforms such as Steam and Valve. So if people are playing League of Legends or Counter-Strike or one of these shoot 'em up games, then those have APIs. We can pull out data. We can start looking at patterns in the data, etc. As I mentioned, we're not trying to scrape the web. We're not trying to, write web scrapers that can pull out information from LinkedIn or Facebook or TikTok or Snapchat, etc. And so that's our focus is very much on, anything with an official API where officially we're allowed to collect the data, then we do. The interesting one was Instagram, where we were collecting that. They had an API. They were bought over by Facebook, as you're probably all aware. And then, certain incidents happened, especially regarding Cambridge Analytica, and suddenly Facebook started taking a much more considered approach about any kind of external access to that data. And so we were collecting a lot of the Instagram data, but as of about 1.5 years ago, that we've stopped collecting that data now. Just as a general, we've been using this kind of data sets for all kinds of different things. I have a project funded in Australia called the Australian Data Observatory, where we're literally trying to get all the social media ever made in Australia. I guess that's kind of the goal. So we're collecting data from all of these different platforms, and I've had several hundred master's students and dissertations I've supervised looking at a whole range of challenges or issues in using this kind of data. We've done work looking at movement patterns, how do people commute around the city, or how do the people just generally move around the city, never mind commuting. We've looked at things such as pandemics and health. We've done a lot of work in event detection, so changes in sentiment on certain topics. So a famous soccer match where Germany beat Brazil for 7-1 as one example, but we've had many, many of these, as well as using the data to look at sentiment analysis and using sentiment on topics to try and identify who will win the election, or will the stock price go up or down, or many, many things like this. But this is the Data Observatory. And we've been building a lot of these things on large-scale cloud infrastructure in Australia. As I say, I teach cloud computing. This is what you're seeing here is the data center at the University of Melbourne. Every year for the last 8 years, I've been teaching a class. I take the students, teach them the theory about cloud computing, and then we take them for a visit of the data center and show them how a real, operational data center, functions effectively, as well as, the sort of big data technologies that we now have through the cloud. So we teach them things such as Hadoop and things of that nature. So this is kind of the context in which we've been working. And so looking now at what are we trying to do in this specific project? So why would we want to link accounts across social media platforms? Well, one of the things, as people are fully aware of now, it doesn't take very much for information to be thrown out. And there's been lots of interest, and the whole world now is living in a very strange environment where information is being put out and people believe it or don't believe it, as the case may be. This whole vernacular of fake news is now out there. So we have lots of people pushing out information. And the thing is, you don't need a lot of people to put out information. You can have a few people who then their information gets dispersed on a very rapid manner, and they can use multiple platforms for this. And sometimes they're sending information out which may or may not belong to them themselves. And we've all seen the impact of this right now with Brexit and the hospital, the monies that were going to, instead of being spent on the NHS in the UK, it's being sent over to sponsor European things, etc. And depending on your platform of choice, you either get the left hand side, which is like the CNNs of the world, and then you have the right wing side, you have the Fox News, and you have all these people pushing out information. It's kind of hard to understand who's saying what. But the key issue is that social media is a perfect vehicle for this. You have generally anonymous users. Anyone can set up a social media account. They can throw out information. They can set out information across multiple platforms, and that can then be consumed and used by literally billions of people in near real time, and that can be used for influencing elections or national policy, etc. And so in that context, it's very important to be able to identify if these are the same people who are putting out news across different platforms, then you want to know that. Some people are very obvious about it. Some people are less obvious about it. And I guess part of the work is it's the less obvious. It's the international sort of attempts, let's say, to change the policies and decisions in countries for whatever agenda is at stake. And that's kind of one of the reasons why we want to be able to say if this account belongs to the same person or same people across multiple platforms, then we want to be able to know that. So that's kind of the general idea of what we've Zhejiang looked at. So could we identify if two accounts on different social media platforms belong to the same person? So, I mean, for some, it's obvious. If I was using my Twitter, I'm R.O. Sinnott. Okay, you know this. For others, it might be someone's called Hotdog47 or Boaty Mac Boatface, but that could all be the same person. There is no official sign up to prove your identity when you're using these platforms. The usernames, the avatars, the screen names, you pick them, and they could be arbitrary, or they could all be a variation of your name, for example, your surname or your soccer team or whatever it might be. So the question we have is, given these randomly allocated accounts that exist across platforms, can we identify if they are potentially belong to the same people? So that in turn says, how similar are these accounts? So how could we identify if two accounts were the same or similar and potentially belong to the same people? Well, different platforms have different information. You typically have an account profile. You'll have an account name. It might be R.O. Sinnott or Boaty Mac Boatface, etc. You might have an image, a picture of yourself or a picture of your dog, or something which is, I'm a Liverpool fan. I might have, a picture of Kenny Dalglish or a famous soccer player in the image, etc. So that's one level of information we might be able to use to match accounts. The actual topics I'm talking about, if I like, certain themes, if I'm a Liverpool fan, I might post about Liverpool, or I might post about University of Melbourne, and I might do that on different platforms, etc. I can also have, there's other information available as well on these platforms. So you can have direct links between the platforms themselves. So I can tweet or say, here's someone who's just in the image here, they've tweeted, but they put a link to an Instagram account where they put a picture as well. So you can have direct links between this person is tweeting and this is the account on Instagram that they're connecting to. You can also have account binding. So if people are using, say, Google to log into platforms, that can also be in the profile of users. And so you should be able to say that the account information, how they logged in, was the same. So that's one way of checking. That may or may not always exist, however. Another is the stylometry, so the style of writing, or they're talking about similar things, or they're using the same emojis, or they have the same content and topics they're talking about on a regular basis, is an indication of potential similarity. And another one, which is the networks themselves. So it's highly likely that people who are following certain people on one platform will probably follow them on the other, and similarly that the people will follow others on different platforms. So we have all of these different sort of attributes we can use to potentially try and identify if two accounts belong to the same people. One of the challenges in this, though, is that not all of these attributes are in all platforms. And so we have to deal with that situation. All of these platforms have various levels of information they capture about the individuals themselves. In this work, we explored a range of platforms. For the most of the work I'm going to talk about, it's largely been on Instagram and Twitter, which is arguably the more sort of established with the platforms with APIs, I guess. So there's less people using Flickr and Foursquare and things of that nature, and other platforms such as Facebook don't give us an API, etc. So as I say, we've been collecting a lot of this data for a long time, and we use a range of information, which is to try and match if the accounts belong to the same people. We had about 200 gigabytes of user profile and posts from these platforms, and about 100,000 accounts that we were using for the experiments. And we identified 34,000, just over 34,000 positive samples. These were accounts which were belonging to the same people on Twitter and Instagram. So it's the same person had these accounts, and they were used for a lot of the experiments that we did in this in the work. So the first thing we wanted to explore is, can we use the profile images? So some people might have a picture of themselves on their profile. So you can have your face, you can have a picture of your dog, or it could be anything. So in doing this, that Zhejiang looked into using, there's services such as Microsoft Cognitive Service, which basically provides an API where you give it images and it will give you the content of the images and classification of the images. So looking at the facial versus non-facial, you can sort of see, it's interesting to note that not many profile images include a face effectively. In fact, it's only about 18% of profile pictures are someone's face. There's a lot of other information included, such as the fonts, the logos, the text, etc. And a lot of the time, this is where, a lot of people who are using, say, Twitter are companies or organizations, etc. So first off, the profile images, we have a very limited way to connect if those people really have the same faces on two platforms, the same profile pic, effectively. Another thing we can do is we're looking at, so I might not have a picture of my face, but I might have an avatar with some sort of image associated with some face associated with it. So what we did here is that we can take those images on the avatars, we convert it to a vector, and then we applied some machine learning approaches using ResNet, AlexNet, and the Microsoft facial recognition algorithms to see if we could identify if the images, irrespective of whether it was someone's face, was a reliable source of identifying if it's the same avatar used on different platforms effectively. As I say, we applied a range of approaches. We found out that ResNet was the best overall approach with an average accuracy of 79% with a medium of 77% accuracy. One of the reasons for that is that it keeps smaller features across the various neural network layers it provides. Another factor in challenging in this work was that a lot of these images are poor quality, so they are not high resolution gigapixels kind of information. You're literally dealing with small, often blurry images, which are not high resolution, so 150 by 150 pixels. So some of the benefits from other platforms, such as the Microsoft ones, were diminished there. And so we couldn't completely rely on the avatar as the source of the accuracy of the face. Another way of potentially identifying the same platforms is the usernames that people select. So we selected just 4,894 positive user pairs of people that have the same it was the same accounts, and then we tried to explore how much could we depend upon the username as being the source of reliable accuracy. This is probably the most obvious one to pick. The same user account name on Instagram and Twitter or any other platform, you would kind of assume that that's probably the same person. Not always the case, as people know. There are lots of challenges in that space where there are billions of people choosing names all the time. And so you can't always guarantee that it's the same. It's first in, first service a lot of the time. But using the exact matching of the usernames, we achieved a 78% accuracy of it's the same account, which is kind of what you would expect. If we applied fuzzy matching or substrings to the account names, then that drops down to 44%. And as I say, that's kind of, there are billions now of people who are using social media platforms, so that it's, the likelihood that you're going to have similarities in names associated with different accounts. A perfect example that springs to mind is Scott Morrison. The Scott Morrison account on Twitter doesn't belong to the Prime Minister of Australia. Somebody else had this, and so It's, he's Scott Morrison MP, I believe. So he has to have the MP at the end to be able to identify, it's that account and not somebody else's. But nevertheless, you can see that we have a 64% accuracy if we just use the username similarity as the basis for the matching. So that we also have a range of information in the user profiles, which is we can utilize to see if it can identify the same people. So people, when you're using, say, a platform like Twitter, you can have your user name, or you can also have a screen identity, the screen name that you're using. And sometimes these are the same on platforms, but not always. And so a lot of the times platforms will use emojis, and there's been lots of work looking at, do people tend to use the same emojis on different platforms? And short answer is yes. In the profile, however, this isn't talking about the actual text or the posts or the tweets they're making, just in the profile. It's far more common to find emojis in things like Instagram than it is in Twitter. So because of that, there was no way that we could possibly connect accounts based on emoji use in the profile, so we didn't consider that. The actual text, when you set up an account on a platform, you typically say, I'm a professor at the University of Melbourne and I like blah, 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 you're describing, etc. You're probably going to have similar kind of terminology or phrasing on different platforms. And so analyzing the profile information was something we looked into. In this work, we looked into the SIM system, which focuses specifically on short sentences, but there's lots of approaches for doing natural language processing and similarity of text and things like that nature, using BERT and Robert and all these kind of new algorithms that are coming out. And the final thing that we can use is the hyperlinks that connect to accounts, as I mentioned previously. So a lot of the time you can say in your Twitter profile, I'm also, Rich Sinnott on Instagram, etc. in your profile. So using that self-description in the profile, we explored how accurate we could identify the two accounts as being the same. We used a range of statistical measures, the Jacquard index, the Sorensen, and we also used Google Universal Sentence Encoder, so GUS, I guess, to explore that topic. And as you see, we have a mixed result, I guess, using the profile information with the best average being the positive identification of the Jacquard of 51%. But the results here are not as great as you would imagine. So people who do use different platforms can actually use them for different purposes. I will use Instagram for my pictures and things I'm interested in, etc. But I will use Twitter to, on my work front. So these two, the language I'm using might be different, for example. A lot of these platforms allow you to have URLs in the descriptions as well, but in that, we only found about 4% of people would have the same URLs in the different platforms. So this might be, I'm Richard Sinnott, and my website is eresearch.unimelb.edu.au, etc. But very, very few people do that. The next thing that we looked into was the actual posts and the tweets themselves. So that's kind of, there's a range of things that you can look into there. So first thing, as with most in dealing with these data, you have to clean it all. You tokenize, you get rid of stop words, you get rid of punctuation, non-ASCII, and you remove URLs, etc. And then in this work, we looked at the average and the maximum post similarity. So what's the average similarity between posts and what's the maximum that you will get? And we only found a very weak similarity of text in posts using the Jacquard and Sorensens, but with the Google approach, the GUS approach, we had a much stronger correlation, which we then use this as the basis then to try and identify or to infer associations between the user account pairs. So there was a striking difference in the level of accuracy we were getting. So from 6% median to 73%, this was hugely different. I mean, so we've got a bunch of attributes now that we've identified as potentially useful for re-identifying or connecting identifying people as having the same accounts on different platforms. And now we wanted to know, is there any correlation between those attributes? So we did a chi-squared test, repeated multiple times, with the results showing here. This is the sort of self-description, the text, etc. We also looked at the topics that people have, we did topic modeling as well using supervised learning, using something called uClassify to identify if the same people are talking about the same things on different platforms. We saw no strong correlation whatsoever between the individual attributes that we were considering. So this was kind of interesting to note. And so what we then did, we took each of these attributes and we then tried to look at either a linear correlation or a cross-feature model. So applying a neural network to learn what are the sort of how these things might be related. So using only the profile information, which we regarded as real time because you can do this fairly rapidly, we're not having to process all of the text and all the images, etc., that are being posted, versus what we call the batch, which was using all of the information. In this case, now we're using Instagram, Twitter, Flickr, and Pinterest. And we used 80% of all the data for training the models and 20% for testing. And for the model itself, we used TensorFlow. And we pretty much, I agreed that if the score of the match was greater than 50%, then that was a match effectively. That's kind of one of the simplifying assumptions we made here. But with that, if we're using all of these attributes and trying to learn all of these features, if we feed it through the cross-feature model using TensorFlow, then we were getting incredibly good results. Basically, we were getting an F1 score of 93% and precision of 98.4%, which is pretty impressive stuff when it comes down to trying to re-identify the same accounts belonging to the same people. So just to summarize, we got pretty impressive results in trying to re-identify the same accounts from across different platforms. There are negatives of this work as well, most notably privacy. People may well have very good reasons to use different platforms for different purposes, and being able to re-identify who may not always be in the individual's interests. There are lots of other extensions to this work. We didn't focus on location information, so the latitude or longitude of where you're tweeting or posting from. One of the reasons for this is that nearly all social media these days doesn't have that. I mean, we're collecting terabytes of data, and I'd say we're now down to 0.4% of tweets have a geolocation included. Extending it to other social media platforms is another extension to the work. There are some challenges that remain as well, and that includes, the evolving nature of this space. So, we've all seen what happened with Cambridge Analytica and how, profiling people and the population at large can happen. And this, is one of the issues that we are acutely mindful of. The amount of data that we're collecting is growing a lot. So whilst we're using a national cloud system, which has petabytes of storage, we're not going to be able to keep all of the data. We're not, resourced to collect all the tweets, all the Instagram posts, all of the Reddit posts, etc., and the subgroups and all this kind of stuff. So there are a never-ending sort of challenge of how much of this data are we keeping and for how long. And probably more importantly, a lot of the time we're dealing with, this is an evolving challenge. So when we think we can identify the same accounts, then if national agencies are trying to influence an election or whatever it might be, they're continually improving the way they apply their tools and techniques for doing this. They're not as trivial as the examples that we've largely based this work on. And that's something for the future for us to consider as well. Thanks very much. Talk soon, folks. Cheers now. Bye-bye.